So I should tell one joke before we have a little bit of time. So, did you hear about the engineer that went to hell? Just say no. Oh. Well, he gets down to hell and he says, this place is a mess. So in 2 weeks, he's got flush toilets going. 2 more weeks, he's got air conditioning. So God and the devil are talking. And God asked the devil, how's it going down there? And the devil says, it's great. We got this engineer. We got flush toilets. We got air conditioning. God says, engineers don't go to hell. You send them up to me. The devil says, no way. We like them. The devil says, we're keeping them. God says, you send them up to me or I'll sue. The devil says, where are you going to get a lawyer? Now you've got this pump. What's the pressure? Unfortunately, these are all the same pressure, atmospheric pressure. And you will see just about all of them used. Gauge pressure, pounds per square inch, inches of mercury, millimeters of mercury, torr, millitorr, Pascal, bar. If you're writing a technical paper, I think they all want them all to be in Pascal or bar. I kind of grew up with torr. It's still very commonly used, so you'll see that in most of the slides here, but you can make the conversion. Sorry about that. So we're going to look at 4 types of pressure measurement gauges. What time does food come here, so I know what? We are providing lunch. You're a captive audience. So, Borden gauge, thermocouple gauge, Baird-Alford ion gauge, cold cathode gauge. These are all very common and often used, so you get to play with all of those. So here's your x-axis again with increasing pressure on the x-axis. The Borden gauge you'll see is something you're using for just, do you remember the pump down in the brake of the tanker car? That was a Borden gauge that you were looking at there, and it just showed a certain value. It's also used for doing very high pressures. Thermocouple, convectron or Pirani gauge, cold cathode gauge, RGA. Same problem with the pumps. One measurement device doesn't cover everything. So you'll need something to measure your rough vacuum and something to measure your high vacuum. All right, Borden gauge. It's just a tube connected to a pipe. As the pressure increases, you're going to see the pipe bend. You'll see it in the video. That motion is converted into an indicator here. All right, so we're putting in 90 psi. And then we're letting it out, putting in 90 psi. How's this thing work? It's really, if you've never seen one of these apart, it's kind of eye-opening. So here's what's happening. That's it. You can see this is, do you think this would be an extremely accurate gauge? No. How common is this gauge? It's everywhere. So on your regulators, you'll see these. If you've got a pump on your pool, you'll see it. They're just everywhere. And that's all it is. You're just opening. Do you want to run it one more time? I think that's good. Would be a good idea. Thank you. Pressure is going up 90 psi. You're seeing this big swing on this. And if you look at how this is geared, you'll see this small motion is translated into a larger motion, and that's what's moving your needle. That's all it is. Thermocouple gauge. Pretty neat. And thermocouple gauges, pretty simple. Heater wire and a thermocouple wire. 4 wires. How does it work? 10 to the minus 3 torr. So this is something you're going to use for your 4 pump. The Borden gauge won't get you to 10 to the minus 3, and you wouldn't trust it anyway. So this is your gauge used for checking your for your 4 pump. No temperature change below 10 to the minus 3. The change in the temperature of the heated wire is measured with a thermocouple. Heat transfer of the wire increases with gas pressure. More gas, more heat loss, lower temperature. You cut it open. I remember when Roberto first cut one of these open, we looked at it. You got these 4 little 4 connections here. There are 2 wires and they're joined together at the middle. That's it. $500 now? I don't know, something like that. But that's all that's in there. They're pretty rugged. I've seen one filled with oil. We drained it out and put some solvent in it. Kept working. Does anybody recognize this pin pattern out here? You wouldn't. It's the same as what was used for vacuum tubes. So your vacuum tube pattern, and they'll have like 10, you think there's something really good here, you've got like 10 connectors, but there are only 4 of them hooked up. But if you're wondering why, that's why. It was just adapting to an older technology. So 2 wires just touching each other. Here's an example of one. This is on a couple $1 million instrument, same old little gauge. Now there's another one which is similar. It's called a Pirani gauge or convectron gauge, and you see this fairly often also. 1 wire. It uses a single platinum filament. Hey, I think we've got that over there somewhere. We'll have to look for it. The gas pressure is determined by measuring the current needed to keep the wire at a constant temperature, and it's supposed to be mounted that way. Measuring the current needed to keep the wire at a constant temperature. So, do you want to hit the video? We'll just show them that. I know we've got one apart. We brought a lot of stuff, but there's always more. We'll play this twice. So here's the temperature. And here's the current. And it's going to control the current based on the pressure that's there. Fewer molecules, lower heat emission. So let's run it one more time. Temperature and current. Electrical current heats up the filament. So a pretty neat design, just 1 wire on it. I don't know what they cost, so I'm sure that I'm not sure. More molecules, higher heat emission. Fewer molecules, lower heat emission. And you're regulating this. And then you need, besides this little gizmo, you've got to buy a controller, which is going to cost you maybe $3,000. So it's changing the current to regulate it, and that current then is being fed back to something which says your pressure is now this. Now, I have my favorites. So this is my favorite gauge, the ion gauge. So in this case, I'm going to put current through a filament. It's going to emit electrons. The grid is positive, so they're attracted to the grid. And now I've got all these electrons in here, which ionize the gas. The ions tend to be positive. They're attracted to a negative ion collector here. And again, you have something to calibrate this to get your pressure. This is a nice video. So we'll play this 10 times? No. All right, so here, and thank Roberto for finding these. So here's the cathode. Heat up a filament, you get a lot of electrons off. Electrons are attracted to the grid. The ionized particle comes here, and we get a reading. If there are more gas molecules, then this current is higher. This is a very reliable gauge in terms of measurement. The Borden gauge has some issues. The cold cathode gauges have some issues. That's why I like this one. If I want a measurement I can trust. What's the catch? You've got a filament in here. Has anybody ever opened a vacuum system to air with the filament on? But they now make these with thoriated iridium filaments, and they're much harder to burn out. The other ones just see the smoke and a gray cloud in your vacuum chamber. Okay, we can go off that. So here's an example of thoriated. You can tell thoriated iridium filament is a ribbon. The tungsten ones are just a coil that you'll see. Here's the grid and your collector here. What's the other issue with these? They are hot. So if you put your hand on there, you will take it off. It's that hot. So that area of your chamber is a little baking out region. This is again on a mass spectrometer. Now, the next one is a cold cathode gauge. This is a pretty neat gauge. Not that big. It's got a little magnet on it, and it's got high voltage, a couple thousand volts. This is one of those items that has high voltage on all the time. The other one is your ion pump here. We were showing that before. That's about 7,000 volts, and your cold cathode gauge is about 2,000 volts. So because of this high voltage in there, you can get a discharge. The discharge will ionize the gas molecules. You've got a magnet in here, so you get cylindrical paths for those electrons. And the gas is ionized and then attracted to the cathode. Cathode then has more current if there are more gas molecules, less current if there are fewer. I think there's a video for this too. So electrons have orbital trajectory. That's the reason for the magnet. The ionized gas molecules are attracted to the cathode. The number of ionized molecules is proportional to how many molecules you've got. Erratic readings with this gauge usually indicate to clean the electrodes. So I've had these gauges turn on and say that your pressure is 10 to minus 10. It's not. It's maybe 10 to minus 5. So in that case, believe it or not, you take a piece of wood and you bang on this a few times. And that will often throw up the problem. So yes, we keep a wood stick next to your cold cathode gauges. And those are $1,000 now, I think, something like that. So here's a video. Take it away, Toby. Discharge, here are your electrons. Gas molecules hit, and then it goes to it's ionized positive. You'll get some negative ions, but in general, most of the ions are positive. And you'll see, this one gives you little bumps. we make this into a video game, is there a payout too? Right, so pressure, current. You've got helical paths for the electrons, they ionize it. It's all in that little container. They have gauges now which are composite gauges, and it may combine the features of the thermocouple gauge and the cold cathode gauge in one. And those are $3,000 now, something like that. So why am I mentioning these prices? Because if you're building a vacuum system, make sure you have enough money, because you don't want to have this little pump pumping this big chamber. I've seen people doing that. And that way, your whole career, you're working with that little pump and that big chamber. You don't want to do that. See the discoloration here? That's an indication that it's been used some and it may be getting some crud in there. And these should be mounted this way. If you mount it this way, then your chances of getting crud in there are higher. So these are instruments in the analytical facility. These are these composite gauges or cold cathode gauges. This one just says a cold cathode gauge. We're going to start with something which is very important, and that is gas cylinders and regulators. We're also going to go through the rest of the stuff, because you've got this system, you've got a pump, you've got a way to measure the pressure. So what are you going to do with it? You want to put things in there, you want to have other connections. So there are traps to keep the system clean. How do you make the connections? And then the valves, the feed-throughs, and the tubing fittings. Gas cylinder safety. I believe this was in Russia on a highway. He's driving a little too fast. What's he have in there?
Yep. Oh, it gets worse. So we're about to see.
There's the driver.
Yeah, we're about to see multiple levy of these. A levy is a boiling liquid evaporative vapor explosion.
And who knows?
The gas oil valve and the pressure relief valve release most of it, and then when it gets so hot, it explodes in a big kind of way. You can find videos on the internet of levies where there is a tanker from like a train that goes shooting off.
So, what's the music we're playing? Once the fire gets hot enough, then all the other cylinders.
It's all gonna go.
Do you notice everybody leaving further away? The traffic on the other side of the road is
There's gonna be a
They just got to leave. See this one? You will all have this video.
because there's multiple gas cylinders.
This one gets hot enough, and then the next one gets hot enough. And then I think the truck's pretty much gone. Yeah, not sure. What was left of the truck is also gone. Do you see that one taking off?
And it just launched, and then it just kept on going out of frame.
We're just about out of gas cylinders.
Yeah, they found the silence.
See that one?
Yeah, there it goes. See, now the lawman goes, whoa, 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 whoa. I've watched this film multiple times.
So we're going to talk about gas cylinder safety. So some technology you should be familiar with. Cylinder valve. Turns on and off the gas to the cylinder. Delivery valve or flow control valve. This is the one you're opening to your system. In between is hopefully a good connection and a regulator so you know what you're putting in. The regulator has a cylinder pressure, which measures the pressure in the cylinder, and the delivery pressure, the pressure you're going out with. So cylinder valve, delivery valve, regulator, and the cylinder pressure and delivery pressure. So very important. What kind of gauges on the regulator? Borden gauges. Extremely reliable. Anyway, that's what's on all your regulators. So there are two types of regulators. I think most of what you'll see are the dual stage. What's the difference? The dual stage, as the gas in the cylinder runs out, keeps the delivery pressure the same. You'll also see something that may look like this. That's a pressure relief valve. So if the pressure gets too high, then it will release gas there. So if you see that, then you'll know that you have that on them. Most of the regulators you see will not have that on it, but there are certain ones where you will. And you want to be especially conscious of that if you're working with something nasty. The regulator has a little connector on it. Those are actually precious. That's where your seal is. So even a little dent in it means it will no longer seal properly. And there won't be any Teflon tape at any time on the regulator. There's something called CGA fittings, compressed gas association. There are a lot of gases. Some of these gases you can't miss, so one regulator doesn't fit all. They have some of them left-hand threaded. And how will you be able to tell that? It'll look something like this, and you'll see the little crease that's there in it. You also know when you try and put it on, it won't work. And there are certain ones for certain gases, and they're all specially designed for those. Many different ones. So this is your most common one: nitrogen, helium, neon, argon. Why? Because unless you fill the room with it, they're something that you've got in the atmosphere. Not going to be a problem. CGA 330, that's a left-hand thread. Hydrogen chloride, hydrogen bromide. So the left-hand threads are often used for something that's nasty. And here's another one, 320. Some of them have washers. There are all kinds of different fittings. Because they didn't have, you only have so many configurations and things you can use. You've got so many different gases, so many regulators. So I think that was the main reason. Two reasons. One is, I think in some cases they said, hey, this is better for a nasty gas because you won't be able to put it on. And number two, that there are only so many fittings. So now if I do left-hand thread, I can have the same fitting left-hand and right-hand thread. But take a look at the list. And then For lecture bottles, there's another whole set, another set of them. Won't go through the calculations. 2,000 psi is low. What's the force outward? 1,568 tons. So, approved methods of storage. That'll work. That'll work. You'll see these in our lab quite a bit in the analytical instrumentation facility. Those are all ones that will work. Do you want to hit the video then?
When a typical cylinder is filled to its design,
can you hear that?
2,400 psi, it will contain almost 300 cubic feet of atmospheric pressure gas, or about 160 times the internal volume of the cylinder. This compression of gas represents a tremendous amount of stored energy. If the outlet valve is broken off, the sudden release of compressed gas will turn the cylinder into a missile with energy to shoot through a cinder block wall.
Go through Mythbusters.
In one reported incident, a damaged cylinder penetrated 2 sheet metal walls before becoming airborne and exiting through the roof. The tank reached an altitude of 140 feet before falling back through the building roof a second time. When a steel cylinder becomes a projectile, it can move with great force, at high speeds, and in unpredictable directions, with the potential to cause serious or fatal injuries.
Hey, we live in North Carolina. Who knows? You know, stay away. I'm still not sure how they. You know, never mind. Here's another one, another little video. Watch this guy carefully. Here comes the cylinder. We'll run it a second time. Wrong place, wrong time. Run it again. I don't think he had a cylinder cap on. What do you think?
No, he did not. It takes a lot of force to break one of those rings off.
Okay, so now we're going to show you how to, we're going to move that to the front here, and we're going to show you how to take off a regulator, put on a regulator, and do it safely.